Derivative of sine x is equal to cos x. Now this formula would be used to write integration of cos x dx would be equal to sine x. But the sin x is not only the function, there is actually the whole family of the function whose derivative would be equal to cos x. Let's take derivative of d by dx of sin x plus c. Sin x plus c. C is can be any real number. There are infinitely many real numbers. So this family contains, or this family has infinitely many members, right? Graceful family. Now sin x plus c is cos x also, because the derivative of the constant function is going to be 0. So we write rather integration of cos x dx is equal to sin x plus c. Since differentiation is inverse process of integration, inverse process, like you take some water and make ice of it, put this into refrigerator, and then again you take out that ice and increase its temperature, then it's going back to be water. Water to ice is a process, and ice to back to water is the inverse process. Another example in mathematical life, like addition and subtraction. Addition is a process and its inverse process is subtraction. Similarly, differentiation is a process, its inverse process is integration. So we actually find derivative of some important function using this technique. Means we know derivative, so integration, right? So that is known, these formulae are known as standard formulae. And let's have a look on few formulae and their antiderivative or integrals. The very first function here is x to power n plus 1 by n plus 1. Now, if you differentiate this function, you will get x power n. That means integration of x to power n is x to power n plus 1 divided by n plus 1 plus c. Look at the other function, derivative of x is 1. That means integration of 1 dx is equal to x plus c. Derivative of sine x, this example we have just seen, and derivative of negative cos x. Why we are taking negative? Because we know derivative of cos x is negative sine x. We do not want negative sign in the formula, so we shifted that negative, means we multiplied both sides by negative 1. So derivative of negative cos x is equal to sine x. That means integration of sine x equal to negative cos x, right? Derivative of 10x is sec square x. So derivative of integration of sec square x is 10x. Derivative of negative cos x, same region. Look, as far as the derivative is concerned, derivative of the trigonometric function starting with c, like these are complementary of sine is cos, the complementary angles. So their derivative is always negative. Derivative of, what we are saying is derivative of cos x is negative, derivative of cot x is negative, derivative of cosec x is also negative. So that is the key you can hold. We have three techniques here, three tools here that will reduce our function into the simpler function, and then we'll integrate them. The integration by substitution, integration by partial fraction, and integration by parts. All these three methods are going to reduce our function in the form where we can integrate it using our standard formulae. So we are going to learn the integration by substitution, and for that we are going to do a little bit of warm-up exercise. Warm-up exercise is important because mathematics is just like a sport, and if you want to enjoy a sport, you need to do a proper warm-up before starting this sporting activity. So we have a warm-up exercise. Integrate the following function with respect to x. So integration of, your question is integration of sine of mx. Now this is not in standard formula. Only difference is that this angle mx is a function of x. We have the formula. Standard formula is integration of sine x dx is equal to negative of cos x plus c. Integration of sine x is negative of cos x plus c, but this is sine mx, so we are going to substitute. Put mx is equal to t. If mx is t, m differentiate both sides with respect to x, so this will imply m is equal to dt by dx, dt by dx, or we can say m dx is equal to dt. Can we find the value of dx from here? Well, dx is equal to dt divided by m. Okay. Now our aim is to change this integral in variable t. So our integral I will look like integration of sine mx means sine t, and dx, this dx can be written as dt by m multiplied dt by m. Now look, this function is reduced in standard form 1 by m sine t dt, and integration of sine t we know 1 by m as it is. Integration of sine is negative of cos t and plus c. So negative sign can be written in front, negative 1 by m, retain the value of cos, retain the value of t, which is 2, no, it is mx, mx, and plus c. That is your answer. So this is the first warm-up question. We have a couple more. Yes, let's see this one. 2x sine x squared plus 1. So we are going to integrate. I is equal to integration 2x sine of x squared plus 1. Now, what should we substitute so that this function gets reduced to any of those standard formulae? Well, whenever you substitute, we normally substitute a function whose derivative is also given. If you look here carefully, you find this function is x squared plus 1. Consider this function. Its derivative is 2x. So that gives us hint that we should substitute. We should put x squared plus 1 as t. So the derivative of x squared is 2x and derivative of 1 would be 0 equal to dt by dx. So we can write dx right here. 2x dx is equal to dt. It can be written like this. Now the integral I, look, this part 2x and dx together, 2x and dx is equal to dt, and x squared plus 1 is t. So our expression can be written as integration of sine x squared plus 1 means t, and 2x dx means dt. Well, sine t dt means integration of sine t is negative cos t. We have seen a moment in the previous question, and plus c, of course. Now we retain the value of this t. So we say therefore I is equal to negative of cos x squared plus 1 plus c. Isn't it easy? Next question is, here it is, which looks a little complicated, but as we suggested, we should take a function whose derivative is also given and substitute that function as t. Here you see there is 10 and sec square x. So it makes perfect sense to change or to substitute 10x as t. But this is 10 root x. So let's put 10 root x is equal to t. So what we are going is put 10 is square root x is equal to t. Derivative of 10 is sec square. Derivative of 10x is sec square theta. So we differentiate both sides, no? So sec square root x and into, by chain rule, we are going to differentiate root x also. And the derivative of root x is 1 by 2 root x. And dx is equal to dt. Now look, this function, we have sec square root x, 1 by root x. Here it is. Sec square x root x, this entire thing is there in the question. So let's write this I is equal to this here. So we get this function integration of 10 to 10 4 root x, means we can write t to power. Okay, let's rewrite this function a little bit. Means, can we say sec is square root x divided by root x and dx is equal to, this 2 is taken to the right, gets multiplied with this 2 dt. All right. So means this part over here, which is circled, becomes 2 dt. And of course, this is 10 root x to power 4. That means t to power 4. So our integral will now look like, let's make some partition here. Our integral I is going to look like, so I is equal to integration of t to power 4, t to power 4 and 2 dt. 2 can be written in front, 2 dt, so dt. Yes, because the constant of integration can be written outside the integral formula. So our answer is now 2 t to power 4 integration is t to power 4 plus 1, which is t to power 5 divided by 5. So this, the formula we use is integration of x to power n dx. So our answer is finally plus c, of course. Whenever you remove this integral sign, you'll see there. So your integration can be written as 2 by 5. T means 10 root x, 10 root x to power 5 plus c. Right? So this answer, because we know in trigonometry, this power 5 can be written here. So, well, let's write it that way. 2 by 5 as it is. 10 to power 5 root x plus c. That should be your answer. We are going to take one more question, and I would like you to suggest a substitution here. The substitution is only to make the question simpler, to reduce this into a standard formula. And we said we should substitute a function whose derivative is also given. So you are going to substitute. All right. Yes, that's right. So you are going to substitute 10 inverse x is equal to, so put 10 inverse x is equal to t. So this means derivative of 10 inverse x is 1 by 1 plus x squared. Dx is equal to dt. So your question looks like I is equal to integration sine of t and 1 by 1 plus x squared here. 1 by 1 plus x squared dx can be written as dt sine t dt. And the integration of sine is negative of cos t plus c. And that is our answer. We will retain the value of cos. So our integral is cos of 10 inverse x, negative, right? Negative cos of 10 inverse x plus c. So we are fully warmed up for exercise 7.2. So that's all for now. I'll see you in next presentation. Till then, keep trying exercise 7.2 and all the very best. Bye bye for now.